Okay, so we're going to start with today's journal with some simplification problems. And this here, you'll see a lot of e's going on for our variable, but just treat them like if they were x's. So the first problem here, we're multiplying two things that have the same base. So if I multiply these two, if they have the same base, I am adding the exponents. So I have e to the 8th power. And that's it. That's simplified. And then for b, I'm dividing e's, and they both have the same base. So I have to subtract their exponents. So this is e to the 2nd power. And then lastly, I'm taking the cube root of 8e to the 9. So if you remember how we take cube roots, we want to take the cube root of the 8 first. So the cube root of 8 is just 2. 8 breaks down to 2 times 2 times 2, 3 times. So that's why the cube root of 8 is 2. And then the cube root of e to the 9th power, so you just take your 9 and divide it by 3. So that gives you e to the 3rd power. And we're done. So right now we're learning all these, we're refreshing on these skills because we're trying to use these basic skills. So that's how to multiply with exponents, how to add, divide with exponents, and how to take the root. And we're going to see that with more complicated problems, but they're still using the fundamental skills here. So let's try out the next slide. Okay, so in this slide here, we're simplifying the expressions again. And you can see with the first problem here, we're trying to multiply this e with this e. So that means I have to add the exponents. So that means I have ex plus this exponent here. So I drag down this x, and now I'm going to drag down this exponent. So I have x plus 1. And so in the exponent here, I'm going to just combine like term. X plus x gives me 2x plus 1. And it looks like that's all I can combine there. So that's my answer. So I'm just going to box that in. For part B, I have an exponent outside, so if I have an exponent outside the parentheses, I have to distribute that exponent to all parentheses, or everything that's inside. So you only distribute to another exponent. Here's what I mean. This negative 2 is to the 1st power, and this e is to the 4x power. So that means that this negative 2 is going to be raised to the 3rd power, and this e to the 4x is going to be raised to the 3rd power. So if I distribute the exponent, negative 2 to the 3rd power is negative 8, right? Because negative 2 times negative 2 gives me positive 4. Positive 4 times negative 8 gives me, positive 4 times negative 2 gives me negative 8. And then this 3 here that's outside is going to be multiplied to the 4x. So 4x times 3 gives me 12x. So this is e to the 12x, and I'm going to box that in. So there we have it. We have distributed our exponent, and we can't really simplify any further anyways. Okay, problem C. So C here is e to the negative x. Whenever we have a negative exponent, we want to make that a positive exponent. So we can't have negative exponents, so we have to change it. So what we do, like always, is we put it over 1. So this e to the negative x now goes in the bottom as a positive e to the x. So now that exponent is not a negative, it's a positive x. And that's it. Part D, here, we're dividing. So whenever we're dividing the same bases, we subtract the exponents. But let's take care of the numbers first. 15 divided by 3 gives me 5, right? So this equals 5. And then the e's, if I subtract 4 with 5, I get e to the negative 1. But remember, in part C, we can't have negative exponents. So I actually have to make a fraction. And e now goes in the denominator, so I can make this a positive 1 exponent. But this 5 here, where does it go? Well, 5 doesn't have a negative exponent, so it gets to stay where it's at. In other words, it gets to stay in the numerator. It doesn't go in the denominator. Now, if you're a little bit hesitant why this is the answer, let me kind of show you what happened. So if you understand C, this is what actually happened. You have 5 e to the negative 1 power is just 1 over e, right? Because e has to be a positive number, or a positive exponent, so it needs to be put in the denominator. And so now, when I look back at this, I'm taking 5 and I'm multiplying 1 over e. Well, I can also write 5 as a fraction. So when I look at this, and I multiply this fraction with this fraction, well, 5 times 1 gives you 5. 1 times e gives you just e. And that's where it comes from. And that's it. All right, so let's talk about the number e. Now, you might have noticed that I've been using a lot of e's in the previous problems. Well, it's because I want to talk to you guys about this really awesome number. It's called e, and the numerical value that represents that is 2.718, and then it keeps continuing on and on, just like pi. This is another irrational number. So in order to represent this irrational number, we call it e, and it comes from this mathematician named Euler. And so I would definitely check him out if you are curious about the math part of this and the history. So Leonard Euler was his name, and he was a Swiss mathematician. And one of his big studies was over limits. And you'll learn about limits in calculus. But for us, we're going to learn how to use e. So e to the first power is 2.718 and so forth, right? So now we want to evaluate the expression to other powers, as you can see here. So let's take a look at e to the third power. Now, it would be awful for you to multiply this out, and almost impossible for you to multiply this 3 times, right, to get e to the third power. So we use our calculator to help us out. If you take a look at the calculator, there's actually an e button. So what you have to do is hit second, which is the blue button, and then you hit ln. Now, that's on the far left side of the calculator. So ln is the button you'll need to press. And then you'll get the e button where you can put in any exponent you like. And if you press that in, you get e to the third power gives me, I'm going to round to the third decimal place, so 20.086. Now I'm going to go back in my calculator and press in e to the 0.7. So if I hit second ln 0.7, so my calculator actually does decimals for an exponent, and I got 2.014 if I round to 3 decimal places. So I'm going to try it one more time with the e that has the fraction, the 1/3. So I have e 1/3. If you want to do fractions in the calculator, you could just do it as 1 divided by 3 and hit enter. And I got 1.396. So I did all of this here, these calculations in the calculator. If you do not know how to do this, let me know sometime during class, because you will need to know how to use the calculator to get these values. You can't do them by hand because it would just be way too tedious. Okay, so now we're going to talk about a different topic. So here we're going to talk about interest formulas, and there's 2 types. There's compound interest formula and there's continuous, let me actually underline that, continuous compound interest formula. Now, both of these do the same thing. They calculate if you're investing money and it has interest on it, how much does that make? That's what the A will stand for. It's like, what's the outcome after you put interest on it for a certain amount of time? So let's talk about what these letters actually represent. As you can see here, I've done some labeling, but let's actually go more deeper in. So P here represents the principal, is what we call it, and you can think of that as your initial starting point. So let's say that I'm opening up a savings account and I put $100 in initially. Well, that's my principal. Interest rate is just the percent of interest that a bank or a saving account might charge you. So let's say that this savings account says I have a 3% interest rate. Well, to use this formula, you have to write this percentage or this interest rate as a decimal. That's really important. So 3% as a decimal is 0.03. Now, if you don't remember how to get a percent to a decimal, well, just remember, you take your percent and divide it by 100, or put it over 100. And if you divide, you get the decimal form. Or if you remember this from elementary school, if you're dividing by 100, you move the decimal place 2 times over to the left. You could do that trick. Or just divide by 100. So now let's talk about time, T. So T represents time, but time is always represented in years when we're talking about using this formula. So time is in years. And then N is talking about the compounding period. Now, compounding means that you are charging interest on your the amount of money you're investing in. So in this case, if a bank were to say I compound monthly, that means that N is 12. If I compound annually, that means that N is 1, right? So that means that I'm charging interest once a year. If I'm compounding weekly, that means I'm charging interest 52 times a year, because there's 52 weeks in a year. So that means that N is 52. So N will change depending on how often you're compounding. Now in the second formula, this is a formula you would use when you're compounding continuously. So you're constantly compounding. So notice that this formula utilizes the principal, utilizes the rate, and interest rate and time. But E is also used in this formula, but N is not. So you don't need N in this formula, but you do need E. So that's why we learned it in the beginning of this lesson, so that we know how to find it on our calculators when we're using this formula. Okay, so in the next 2 slides here, we're going to do few example problems. Okay, so in this problem here, it says, suppose your grandparents deposited $500, okay, and in an account for you at birth, and that earned 6% annual interest. How much money would be in the account after 18 years if the interest is accumulated yearly? So first thing, when we're solving a problem like this, you want to know which formula to use. So we learned 2 formulas. We learned this formula here, which is called the compound interest formula. And then we also learned this formula here, PE to the RT. Sometimes we call this formula here PERT, because the way it's written, it looks like the word PERT. So how do we know which one to use? Well, for this one, the compounding formula, you need to know how often you're compounding. Whereas the other formula, this one, you don't need to know how often you're compounding, because you are continuously compounding. So, if in the story somewhere it said that it was continuously compounding, you would use the equation PERT. So if you read this question, do you see the word continuous? No. So it doesn't look like we're using this formula. So maybe it's this formula here, but in order to use this formula, you need to know how often you're compounding, or how often the interest is accumulating. So if you read this problem, it looks like the interest is accumulating yearly. So what does that mean for N? Well, it means that N is equal to 1 because you are accumulating interest once a year. So if we're using this formula here, let me highlight this formula. So to use this formula, we need a P. So P here, it looks like is 500 because that's our starting amount. We need an R, which is our interest rate. So our interest rate is 6%, so that's 0.06 as an interest in decimals, or percent in decimals. And then we need an N, which, because we are accumulating interest yearly, we are only doing it once a year. We're only compounding once a year. And in this case, time is going to be 18 years because that's how long we're investing. All right, so it looks like we have all our ingredients, so we're gonna set this up now. So if I set this up, I have 500, 1 plus R, which is 0.06, over N, which is 1, to the 1 times 18, because it's N times T. So what I'm going to do is actually put this in my calculator. Okay, so I'm going to switch this to the video mode and turn the video on. Okay, so I think it should be recording. So what I'm going to do here is clear this out, and I'm going to type in my function that I have written out. So it was 500 parentheses 1 plus the fraction. So when you want to type in the fraction, you want to use parentheses. And so 0.06. And I'm going to use a division sign to show that it's a fraction over 1. And I'm going to close that parentheses. So notice that this parentheses only closed the fraction. So you still want to close that parentheses there. So I'm going to use an extra parentheses, and I'm going to raise it to the, 1 times 18? And so that's what I have so far. And this is nice that I've written it this way because I can do it in one go. Just hit enter and get my answer. And there we have it. So I'm going to copy that answer here to the side. Okay, so it looks like I have, what's that, 14.27 and 17 cents if I round to the second decimal place. Okay, so now what I'm going to do is I am going to calculate the quarterly and monthly. So for quarterly, if I'm compounding quarterly, think of dollar and versus quarter. I'm going to be having to compound 4 times a year. Whereas monthly, I would be compounding 12 times a year. So that means I just need to change my n value in that same function that I have here. So what I'm going to do is change those n values here. So I'm going to actually write this out and set it up first. So A is equal to 500, 1 plus 0.06 over 4 times 18. So I'm going to figure out what that number is, and then I'm also going to figure out what happens when I plug in 12. So that's going to be 12 times 18. Figure out that number. Okay, so this next part, I'm going to grab that calculator again and retype that in. But I'll show you a little trick what you can do so that you don't have to retype everything from scratch. You can reuse what you just type in and just edit that n value. So just hang on one sec. Let me see if I can grab, or maybe I'm just going to need to grab another video. So let's see if I do video and I turn this on. Okay, so this was my last entry. So what I'm going to do is hit second, the blue button, and enter. So this gives me the last thing that I type, and I'm going to use my arrow key and go to the 1 and change that to a 4, and this one to a 4. And I get my value. So that one's for quarterly, and I'm going to do it again, but for monthly. So I'm going to do second, enter. I'm going to go back and change this to a 12. I think that overrided a parenthesis, so let me add another parenthesis in. And then it was 12 times 18 and hit enter. So those are my 2 numbers there. I'm going to pause this now and drop this to the side. So it looks like here I have for quarterly, let's see, I have $14.60 and 58 cents, and then I have $1,468.38 for the other one. So out of these 3, which one made the most money? Well, we can see that it was the monthly that made the most money. So that's our winner here. But let's understand why. So monthly is compounding the most compared to everything else, right? N is 12, and it's much bigger than the rest of them. So it's saying that as the more time you compound, or the more time you add interest, the more likely that the investment will grow. And that makes sense, right? The more interest you add, the more likely you are going to make more money. So we're going to take a look at one more problem, and that one's going to deal with more of the continuous compound formula. Okay, so this problem here looks like the exact same problem. The grandparents are depositing $500 in the account, and it pays 6% annual interest. But this time around, it says that the interest rate grows continuously or compounds continuously for that 18 years. So this time, we're going to see how does compound continuously compare to the other three that we did a moment ago. So if we're doing compound continuously, or anytime in the story problem you see continuously, we're using that formula PERT. So in this case, if I'm plugging things in, remember P is 500, that's our initial. R is our percentage of interest rate, so as a decimal that's 0.06. T is 18 years. And if I were to plug this in, I have 500 e to the 0.06 times t, which is 18. So if I plug this in my calculator, here's what it's going to look like. If you haven't figured out how to put in e into your calculator, you might want to watch this. So I'm going to grab my video camera here, turn that on. So on here, if you turn your calculator on, I'm going to press that exact same thing into the calculator. So I have 500, I'm going to grab that e, so that's second ln. I notice I got the e button. Now I'm raising it to whatever power I need. So my power is 0.06 times 18. I'm going to hit enter. So I'll zoom in for you. So it looks like I got 14.72 and 34 cents if I round. So I'm going to copy that onto my problem here. Let's see if I can scoot that over. There we go. Okay, so in this case, I made $1,472.34. So when we compare this with the previous problem, remember the previous problem, the monthly made the most money. This time around, it looks like this one made even more money, right? If you look back at your journal. So it looks like compound continuously is the winner here, which makes sense because if you're compounding continuously, that means you're compounding constantly. That's going to be way more than 12 months. So in this case, you should be making way more money because you're compounding more, you're adding more interest on. So in this case, in general, if you keep all the variables the same, compound continuously will always make the most money. All right, that's it for this journal.